Okay, on 20 through 81. Okay, I didn't know if I answered all of them last time.
You did.
Okay. So here is the last page. So actually the second to last page, 82 through 80. Of the ones that were assigned.
Can you do 82 and 85, please?
82 and 85. Yeah, remind me on 85. I might forget. I'll start with 82 here. Okay, so on 82, it says f of x equals g of x plus 7. So that means I can rewrite this integral. Of f of x, instead of f of x. And then I have a plus g left over. Equals, this is dx here.
You're writing something?
Are you like saying something?
But
I don't see it.
Oh, you can't hear me?
Written.
I think I can't hear or see anything.
Oh, and the other. Oh yeah, the writing's
There's a
lagging
lag.
too.
Fun times.
Okay, sorry about the lag. So hopefully I'll work on something this weekend if there's anything I can figure.
Dude, let's just cancel this. I'm not hearing anything from Sam.
It's so bad, Mr. Morrison. Like we don't like you're underwater. Sounds like you're teaching Krusty Krab.
Let's see what.
Oh. Nice.
If anything, it works for like the first like minute, and then it just wants to go to. Morrison, are you just looking at your screen?
No, I'm good. Hopefully you got enough from that last one. I'll pick up where I left off. Is the sound any better?
I heard like 3 words the last time, but it sounds better.
That sounds better now.
Sounds better right now? Okay.
Like
So I'll pick up where I left off on that
We're
one.
on 82.
Nope, never mind.
82. So I had 2. He said, never mind. Bummer. Okay. Well, at least you can see what I'm writing sometimes. There.
You're writing something?
Yep. Just have to wait for it. It'll come up. Okay, so this is just where I left off last time when I was writing. So it's going to be 2 times the integral from 3 to 5 of x. I think this might be a Zoomish, guessing everyone.
I don't think
Nope.
it's a Zoom issue.
And it's going to come up.
What's coming up?
Blame you here, man, but this is really.
All I heard is it gonna come up. It's not your Wi-Fi that's gonna come up because this is bad.
That's all I said. It's hopefully going to come up soon.
Oh.
So here it is. I haven't been talking much.
Okay, it's better now.
I've just been writing. So I just plugged in 5 into the X. This is where we left off last time. Plugged in 3. And then when you simplify this, it looks like this, which is letter B. So I'm going to do 85 next. I'll give you a few extra seconds because I know you might need to copy that down. Is the audio still okay?
Working right.
What's that, Daniel?
It's cool right now.
Okay. Keep me posted if it's like cutting out. I know there's a lag. Yeah, my guess is there's something going on with Zoom right now, but I'm not sure. Okay, so I'm gonna go to 85 next. So I'm gonna clear this out. Okay, so on number 85, it says a trapezoid. So 2 to 5.
It's not working good.
Oh, yeah,
It's
you're
gonna be
cutting off
3.
again.
Okay, I'll stop talking right now. I'll just write. So the distance, all right, I have to talk a little bit. So the distance from 2 to 5 is 3. I do 30. The distance from 5 to 7 is 2. So is gonna would simplify to equal 160. So eventually I'm hoping it'll come on, but you're doing, there it is. So you're doing half of base times height for each trapezoid. I'm sorry, not half of base times height, half of the height times the average of the bases. So I can factor out the 1/2, so I don't have to keep dividing by 2 when I average the bases. And it's gonna look like that there. So any questions on 85?
Thank you.
That's okay, all right. So other questions on this one?
87.
87, let's look at 87. I'm gonna clear this off. Okay, when you see tangent line, okay. Apologize for the lag that's going on here, but I'm doing 87 right now. So I'm taking the derivative because it's asking to line. So it's gonna prime of f plus 4x. And 1 plus 4x. You'd have to use your calculator to solve this equation, which is right there. So use your calculator. And then you slope in a point. So where the 0.237, and that's going to
You cutting in and out again. We haven't heard like a word you said for like a long time.
Don't worry, man. He just left.
sharing features.
I think it's because they updated it to be more secure, so now it's all buggy. Because people were getting hacked.
Nah, I think it's just because everyone in the whole world is using it.
That too. Or you have McDonald's internet.
How kizzy.
Bro, you got the free internet from the school, Mr. Morrison?
Why are we so mean to him? Jeez.
And
This is how I get treated in fourth period every day.
It's a fourth period thing.
Okay, so right here, where was that? So we had, can you hear me?
Yeah.
Okay, thank you. So here, hopefully these issues will get, we had using you had 0.115. So now I can just use my formula to find the equation. It's y minus y1 equals the slope that's given in the problem times x minus x1. And then when you solve this equation for y, just get y by, it's going to be x minus 0.122. So that'll be letter D. Okay. So any questions on 87? So hopefully you can see they like you to find, they give you the slope and you have to find another way to write the slope, and then you set those two expressions equal. Solve for x, plug x back into the original function to solve for y. Once you have a point and a slope, you can plug it into point slope and get y by itself. That gives you the equation of your tangent line. Okay, other questions on this page? Okay, I'm gonna go to the last page. So 89 through 92.
Can we do 92?
92, yes. Okay, so on 92, this tangent line again, so I'm going to find the slope. So I take the derivative of my function, which is 2x minus 2. And I'm looking for x equals 2. So I'm going to find f prime of 2. So that's going to be 2 times 2 minus 2, which is just 4. Wait, just kidding, it's 2. And then I'm going to find f of 2 into the original function. So plugging in here, when you put 2 into that, that's going to give you 3. It's like the last prime, so it's y minus y1 e the slope to find the slope, it's going to be 2. This is my x1 and this is my y1. So we already wrote y1 3, and then it's x minus x1, which is 2. Okay, so the or gives me a position if I am close to 2 using the tangent line. So right here, I would do the actual value, which comes from the function. My approximation. Here. So this gives you the error. So this is the actual value or approximation. So the actual value minus the approximation gives you the maximum error. 0.5. Minus 4x plus 3.5 needs to be less than 0. When you get 0, just ignore the absolute value and get 0 by itself. And then using your calculator, get an x of 293, another x value of 2.707. And of these two, this would be your max error, 2.707, which is that one there, 2.7. So I don't think you're going to see anything like that, but it's still good practice to look at, finding the error given a function and the approximation. So you're using the tangent line to approximate the y-coordinate of your original graph. So as long as you're close to the point of tangency, it should give you a pretty good approximation. That's your L of x. And we're going to do the actual value minus approximation to represent the error, and that has to be less than 0.5. All right, so any other questions here? We're okay. So for today's, make sure you can hear me. So say yes again if you can hear me.
Yes.
No one say yes?
Yeah.
Okay, so for the extra credit today, you're gonna take a picture of a thumbs up, so maybe like a foot away, and submit that for April 3rd on Google Classroom right now. So thumbs up so I can see that it's up. Take a picture of that and then submit that on Google Classroom right now. So if you're paying attention, you should be able to get 4,000 test points. Okay, so I'm going to switch over to 1997. All we're doing on Monday is just getting caught up. So we're not really, and then the extra credit if we have time, we'll talk about that too. So everyone's taking
Is it? Oh, there.
the thumbs up. All right, so we're gonna switch over to 1997. So these are the non-calculator questions starting off. So what would you like to see on 1 through 8 from the 1997 test?
6.
Number 6, let's look at number 6. Okay, the word normal. We learned why it doesn't show up very often though. Number 6, when you see normal perpendicular.
Can you repeat normal?
So normal means perpendicular. So I'm gonna find the slope of the, and then I'm gonna take its opposite reciprocal. So right here, minus x, and from there, I'm gonna bring left to the front. Which is negative, and then times by the derivative of the inside function. So the derivative of 16 minus -1, a minus here in front, so I'm timesing by -1, and a 0. By time of 0. That's gonna be half times 16 minus 0 to the -1/2. That's going to be -1/8 when you simplify this. And because it says normal, you take the opposite reciprocal of negative, be a, +8. Is that okay for 6? Say yes if it's okay for 6. Need some feedback.
Yeah.
Yes, thank you. Okay, so other questions on this page.
Can you do number 1?
Number 1, yes. Hopefully that dog barking's not a distraction. Dogs are great, though. I love dogs. Okay, so number 1. So when I add 1/2 plus 1, there it goes, I think. Okay, then I'm going to integrate this from 0 to 1. So I'm going to add 1 to the exponent. So when you add 1 to 3/2, it's going to be 5/2. Dividing by 5/2, same as times 2/5. Plus, when you take the integral of x to the 1/2, it's going to be x to the 3/2. You add 1 and divide by 3/2 is the same as timesing by 2/3. This is going to equal, when you plug in 1 for fifths plus 2. When you plug in 0, it's just 0, so you don't have to subtract 0. So just do 2/5 plus 2/3. This is going to be 6/15 plus 10/15, which is 16/15. So just test your algebra skills a little bit on that one.
Thank you.
Can you go over number 4, Mr. Morrison?
Absolutely, Vivica. So number 4. So I'm going to clear this out. Energy number. Okay, so when you see relative maximum, you're going to find the derivative. Derivative equal to 0. So f prime of x equals, wrong one. Okay, when you take the derivative here, I'm going to do product rule on number 4. I'm taking the derivative of this using product rule. So it's going to be factor times the second factor. Well, actually, no, you can write this. You can simplify before you get the derivative here. This is x, e to the ln of x squared is just x squared. You simplify. So e to the ln of anything is just the anything. So e to the ln of x squared is just x. So this would be x, which equals 3x. First part of this one, that squared, you can simplify that to be x squared.
Could you backtrack to number 3? I mean, yeah, number 3.
Yeah, I give you number 3. So on number 3, equal, and I'm going to set this equal. And as I do factor this, but I'm going to pull out a for minus 1. Then I'm going to so to get 5x to the 4th, I'm going to multiply 5x squared and x squared. And then I'm going to get minus 1 and plus 1. More. When it's a difference of squares. 5x squared plus 1, when you set it equal to 0, is going to be imaginary, so you could ignore that one. So you have x plus 1, x minus 1, you set that equal to 0. Positive 1 and negative 2 is a sign chart. This domain is all real numbers. Negative 1 and 1. So right here, I'm going to find f prime of a number less than negative 1. We'll do f prime of 0, then f prime of 2. So plugging into my derivative function on the top right. So when I do that, it's going to go positive, negative, positive. So the max occurs when it changes from positive to negative. So that would be at negative 1. Yeah, I think after like 1998, they focused more on calculus and a little bit less on algebra. So I don't think you'd have anything this algebra intensive, especially in 45 minutes. But you still, yeah, you may be asked to find the relative maximum. I'm not sure about that one.
Thank you.
So anything else on this page?
Can you explain number 7?
Number 7, yes. Number 7. I'm gonna clear this one out and then do number 7. Okay, so we're referring to the graph up here for number 7. Okay. And tangent line. So whenever you see the word tangent line, someone first.
Derivative.
Derivative. So I'm going to take the derivative. So for number 7, I'm going to look at f. If our x coordinate is 3, I'm going to be considering f prime of 3. And I'm given the graph of f prime of x. So f prime of 3 based off of the graph. If I'm given f prime of x, it's just of this graph here. So at x equals 3, what's the y coordinate of the graph?
2.
2. So that gives me my slope, and I am given here a 0.35. So I'm just going to do y minus y1 equals my slope times x minus x1, and that would be letter C. So this one you have to always make sure you're paying attention to which graph is given to you. If it gave you the original function, then your slope would be 0 because it's a turning point. But it's giving you the derivative graph. So that means it's just the y coordinate of the derivative graph represents your derivative at x equals 2. Okay, other questions on this page? Or, okay, so 1 through 8, everyone's good? Last call? All right, going to the next page. Here is 9 through 16. Any questions for these?
11.
Number 11. Let's look at number 11. So this one I'm thinking U substitution. Okay, I'm gonna do something weird, so I'm gonna share this and share it again. This is 97. Rough technology.
Wait, never mind. Can we? I think I realized my mistake.
Okay. So anyone see number 11? So everyone's okay with number 11?
Could you do 13 though?
Okay. 13. Let's look at 13. Okay, so number 13. So we have the accelerator is this. So that means if I want to find the velocity, I have to take the integral of the acceleration. V of t, it's up here. So velocity is the integral of 2t minus 7. So I'm 7t plus c. So I just took the integral of 2t minus 7. Then I have to solve for c. So I'm given an initial condition. It says if the initial velocity, that means when t is 0, is 6, let's find c. So when velocity is 6, is 0. Here. You would then. So this is going to become v of t equals squared and t plus. And what are we trying to do? If the initial velocity is 6, at what time is the particle furthest to the right? So that means I want to figure out where I want to maximize the distance. So I'm gonna see max. So if you were to do that for the position function, you would take the derivative of position, which is velocity, and then you would set that equal to 0. So I would set one. Let me backtrack here. So and -1. So to find, if I want to maximize it, I need to do a sign chart and see where it changes from positive to negative. So since the domain of my velocity is all real numbers, the polynomial, I can do it like this. And I'm going to consider at -1 and 6. So I'm going to do velocity something smaller than -1, like -2. I'll find v of 0 in between -1 and 6, and then v of 7. I only care if it's positive or negative. So here it's going to go positive, negative, positive. So I know my maximum, where it's furthest to the right. If I want to maximize the distance away, it's going to be going from positive to negative. So that would occur at t equals negative. Oh, I factored it wrong. I figured out what I did. So that should be a positive one. So backtrack a second, should be easy fix. I think. So minus, this should be -1. And that means my answer would be 6 and +1. And so +1 is going to be my answer. So again, the key thing here is you have to recognize that furthest to the right is a distance. If you want to maximize the distance, you take the derivative and set it equal to 0. The derivative of the distance or the position is the velocity. So you're setting the velocity equal to 0 and figuring out where, at what time the velocity changes from positive to negative. That would be at t equals 1. It'd probably be tempting to take the derivative of the velocity here, but you don't want to do that because of your understanding of a maximum. It's the derivative of the original function. So what else on this page?
Can we do 14?
14, yes, let's look at 14. Okay, so for geometric series, you need to know the starting term. So this is one thing that part of series you are expected to know. So I am absolutely expecting them to test you on series. They even specified which parts of series you need to know. So I'd be shocked if you don't see anything on series. So I would definitely know the starting term here is 3/2. If you want to find R, you're asking what are you multiplying by from left to right? So to get from 3/2 to 9/16, aren't you multiplying by 3/8?
Yeah.
And to go from 9/16 to 27 over 128, you're timesing by 3/8, and so on. So the formula to find the sum of an infinite geometric series is going to be the starting term over 1 minus R. So this is an R here. So it's going to be my A, which is the starting term, over 1 minus 3/8. So my least common denominator is 8. So I'm going to times the top and the bottom by 8 here. The numerator, 8 divided by 2 is 4. 4 times 3 is 12. When I distribute 8 on the bottom, I get 8 minus 3, which is going to be 12/5, which is the same as 2.
How'd you get the 3/8?
3/8. If ever you're not sure R is the second term and divide by the first term, it would do 9/16 divided by 3/2. This is the same as 9/16 times the reciprocal, 2/3. This mean 4 cross canceled if you wanted to. If you reduce 18 over 48, you divide the top and the bottom by 6. It reduces 3/8. So you're asking the question, what are you multiplying as you go? What are you multiplying by as you go from left to right? And if you're not seeing it right away, just always do the second term divided by the first term. That'll get you there. Other questions on this page? So yeah, 15 was one you could have skipped because it's anything that has to do with parametrics or polar. Even if it's in the extra credit, you can skip those. And those are a lot of the hardest problems I've seen over the years has been based on polar and parametrics. So in some ways, the more I think about it, the more I'm realizing that's actually could be a very good thing that they took off those two topics.
Can you explain number 9?
Number 9. So I haven't heard anyone complain about the audio, so I'm guessing that's okay on your end, hopefully.
So far.
What's that?
You've been doing good so far.
Oh, that's good. That's what I like to hear. So I think it was a Zoom issue. I don't know. Maybe if everyone in the world is using Zoom right now, they're having a hard time handling it. But I could be wrong. I don't know. Maybe it's my issue. I'll play with it a little more. Okay, so number 9. Am I missing something? Oh, this is based on the one that says 7 through 9, huh? So I think you have to go to the last page for this one. That would be funny if that's the question. What value of x is the absolute minimum occur? So I think you have to look at the graph from the previous page. So the absolute minimum. So remember absolute minimum, and I'm going to backtrack. So this is question 7 through 9 using this graph. Let me see the choices again. So the absolute minimum candidates here. It can occur when the derivative is 0, which is here, or it can occur, which is here and here. Okay, so right here, highlighter, doesn't it start off above the x-axis? So it's increasing, 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 increasing. Increasing, increasing, increasing. So the original function look like this. It starts at some increasing, 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 increasing until you get to where x equals 6, increasing a little bit. This isn't perfect, but just a kind of a quick sketch of what f of x could look like. So once you here, where x equals any above the x-axis, that means the original graph is increasing. So right here, the absolute minimum, wouldn't that be at x equals 0? So x equals highest, the absolute maximum, but it's asking about the absolute minimum. So for number 9, the absolute minimum would be at x equals 0. Is that okay for number 9?
Yeah.
So yeah, that's an important thing to remember. When the derivative is positive, the original function is increasing. Don't mix those up. When the original function is negative, I'm sorry, when the derivative is negative, the original function is decreasing. Clear this out. Okay, so what else? We have time. Like I said, Monday, we're not going over any, we're just kind of finishing up this one and then kind of just talking about the extra credit and stuff like that. And you guys know the extra credit is due Monday, right? So that's all out, it's all the multiple choice out of the blue workbook. Make sure you're checking your answers. Make sure you're also working together, because I'm definitely not gonna have time to go over all of them. So help each other. That's gonna be good practice to review a lot of the old concepts. Use your notes when you get stuck, but try to, it's always very important to figure problems out on your own. If you're just copying work or kind of working backwards too often, it's not gonna help you as just doing the problem from scratch, just like you're doing on the AP test. That's where you're gonna get stronger and stronger. Even if you're not getting them correct, as you do them more, it starts to get easier, I promise. But you have to do the problem from scratch and then check your answer at the end.
Mr. Morrison,
Okay. Yes.
it's due Sunday night, right?
Is it due Sunday night?
I don't know. It's Monday at 12 a.m. So that would be like, or it was when I checked. It'd be
Okay.
like Sunday night, right?
I guess so. Maybe I could try to postpone that a couple hours if I remember.
Okay.
Okay, something else on 9 through 16. Okay, going to the next page then.
Oh, sorry. Can you explain from 16?
16, let's look at 16. That looks like L'Hopital's rule to me, because we have 0 over 0. E to the 0 is 1. So 1 minus 1 makes my numerator 0. 2 times 0 make denominator 0. So I would expect you to see L'Hopital's rule somewhere on the AP test. So as h when I take the derivative, let's try plugging in 0 again. So e to the 0 is 1. So you're just left with 1/2. H goes away. Answer is B. In Meyer, how's multivariable calculus?
Wait, it's pretty good. I mean,
Pretty good.
so I already took 2 quarters of it, and I'm doing linear algebra right now.
Okay. Did you
Yeah,
go
I guess
right
I'm
to
done.
you went right to multivariable?
Mhm.
So you're able to skip Calc 1 and Calc 2?
Yeah.
Wasn't that nice to get all those credits?
Yeah, I guess. I mean, I could have like not send my score and then just like take an easier math class, but
Yeah, that's a lot
I
of
didn't
time
want to
and
do
money.
that.
Okay. Hopefully you can just get credits now.
Yeah.
So that will make your life much easier and cheaper in college. All right. So other questions on this page?
Number 10.
No? I think I
Number
heard a
10.
no. Like,
Oh.
no. You said number 10?
Yeah.
Yeah, let's look at number 10. I think we have lots of time now. So I like not having to rush through this. So I'm not too concerned about time. Okay, so number 10. So I think we've seen an implicit differentiation question on every single AP test so far. So I'm going to take the derivative of this with respect to what? It's just a quick review. When you take the derivative of x, you take the derivative of y. So the derivative of x is dx over dx, which is just 1. So this is why the derivative of x to x is just 1. If you take the back to x, you just have dy over dx. So please remember you're doing implicit. Sometimes you have to do chain rule, where you're taking the derivative of the inside function y and get dy over dx. Okay, so number 10, the derivative of when I take the derivative of x, y, I'm going to do product rule. So doing product rule for the derivative of x times y plus the second times the derivative of the first. So we got a little lag going on here. Hopefully it'll come up soon. So I just use product rule. In the derivative of x is going to be x times the derivative of y with respect to x, y times the derivative of x. And then I take the derivative of x squared, which you know is 2x, and the derivative constant is 1. So it says find dy over dx when x equals -1. Well, when x equals -1, we need to figure out what y equals. So it's going to be y equals, I'm plugging in -1x. And I'm trying to solve for y. So when I solve this, 2y equals 2. So y equals 1. So plugging in -1 for x, I was able to figure out the 1. Top, everywhere I see an x, I'm going to plug everywhere I see x, positive y. So when I add dy over dx to both sides, 2 times dy over dx. So this is just combining like terms. Dy over dx plus dy over dx is just 2 dy over dx. When I combine the 1 and the -2, it just minus 1. So 1 minus is negative 1. So this is going to equal negative 1/2. And B. So yeah, this one requires you think about what you need. So in this case, you needed a y. You have to plug in negative 1 for x to solve for y into the original equation. Okay, other questions on this page? Okay, so let's clear that. Now we are on 17 through 23. What would you like to see on 17 through 23?
You're 17.
17. Okay, so 17. I'm glad you asked 17. I could really see one similar to this one being on your AP test. Because again, I don't know this for sure, but I really think since there's no overlap with the AB test, I think it's really a lot on the stuff you learned this semester. Since January when we were doing the packets. So that includes Taylor polynomials. So that's a really big topic for series. They pretty much ask on Taylor polynomials every year on the free response questions. So I'd anticipate they do the same thing this year. Okay, so on 17, third degree, so I'm gonna go to the third derivative. So I'm gonna find the derivative. You can also write this as x minus 3 in parentheses to the negative 1. You find the derivative of 1 over x minus 3. So that's x minus 3 to the negative 1. When you take it's negative 1 over x minus 3 quantity squared. Derivative, it's probably better to write it with a negative exponent. So think of this as negative in parentheses x minus 3 raised to the negative 2. So you bring the negative 2 to the front, makes it a positive 2. So that's going to go in the numerator. And 2 over 3 cubed. Someone saying something?
Isn't it 3 minus x, not x minus 3?
Is it 3 minus x?
Let's 3 minus x.
Oh, you have to do, yeah, you have to do chain rule. So when you take the derivative of 3 minus x, it's going to end up being negative 1. So when you times 3 minus x, when you times that by distribute the negative 1 to that, it becomes an x minus 3. So it's, I skipped the step.
Okay, I see.
Have to times that by chain rule. Going to be x minus 3. So this is just brushwork here at the top. So I skipped the chain rule part in doing it, but yeah, you do have to multiply by negative 1 doing chain rule. Okay, so now to find f of here, we are set at what? X equals, someone tell me?
2.
Equals 2.
2. So we're centered at x equals 2. So that means an f of 2, f prime of 2, f double prime of 2, and f triple prime of 2. So when I plug 2 in, it's going to be ln of 1, which is just 0. When you plug in 2 into a derivative function, it's going to be -1. When you plug 2 into the derivative, it's going to be -1 again. You plug in 2, it's going to be -2. So now, when I'm writing my polynomial, I'm going to so this is going to equal 0 factorial. It's x minus 2 plus something over factorial. It's going to come up here shortly. Something over 2 factorial, x minus 2 squared. Something over 3 factorial, x minus 2 cubed. Okay, so I'm going to take all these numbers. So 0, -1, -1, -2, and those are going to be my numerators. So 0, -1, -1, and -2. The term just goes away. All right, my final answer. I don't see any factorials in the solution in any of the answers, so I'm going to simplify. So -1 over 1 factorial is just -1, so it's going to be negative. Then I have x minus 2. Minus 1 over 2 factorial is just -1/2. You have x minus 2 squared. Lastly, you have minus 2 over 3 factorial is 2 over 6. 2 1/3. You have x minus 2 cubed. So that will be letter B. Another way to write it is letter B. Okay, other questions on this page?
Um, 23.
23. So I'm going to clear this out and look at 23. Okay, so on 23, okay, so right here, I know that I'm just going to write out what I know. I know theta equals opposite over hypotenuse. That's going to be x over 5. Then when I saw okay, so theta is increasing at a rate of, how you would write And it says that what don't do it. See that again. There it goes. Okay. Is increase C equals 3. X over dt for the moment. I'm trying to understand what you're given and what you know. Or sorry, those are the same thing. What you know and what you're trying to find out. So I'm trying to find out dx over dt is x goes to 3. So equation. And I'm going to take the derivative of both sides with respect to time. So dx over d. I'm going to write it down. Dx over dt. Okay, this is going to equal, when you take the derivative of 5 sine theta with respect to t, don't forget it's with respect to t. Okay, the derivative of over dt. And the good news is we know what d theta over dt is. Cosine of theta equals. So now that I've taken the derivative, I can substitute for x. Don't do this until you've taken the derivative. So if x equals 3, you can do Pythagorean theorem now to solve for the third side of the right triangle. So 5 squared equals 3 squared plus b squared. So when you solve for b using Pythagorean theorem, the third side is going to be 4. So I'm going to say that theta is going to be adjacent over hypotenuse, so 4 over 5. So 4. Now I have everything I need to solve for x over dt. Bummer. So I'm going to pick up where I left off. I think I remember where I left off. Okay. You're doing so well for a while. Isn't that happen? I don't know why. It's never done this to me before. It's like kicking me off. Well, at that point, you're just plugging stuff in, so hopefully it wasn't bad. But I'll pick up off at the very end. So that was 23. Okay, so 23, where I left off. What did I have here? So I have dx over dt. Sine of theta d theta over dt. So this equals 5 and then d theta over dt. So this is going to simplify 2 5s are, so you're just left with 4 times this 12. So I can't see E here, but I'm assuming the answer is E12. All right, so questions on 23. And so then I'm gonna be looking into this more. Just can't do it right now because that would be wasting your time. It's on this page. Say yes if you can hear me okay. I want to make sure I'm not talking to myself.
Yes.
Yeah.
Thank you.
Yeah.
That's helpful.
I'm like,
So any other questions on this?
I mean, I can.
Okay, now someone else's audio is having issues. Can you say that again?
No, nothing. I just said I could hear you.
Yeah, I think
Oh,
he's gonna start talking.
you can hear me, okay. All right. So last chance. Go to the next page. Any questions on 17 through 23? Don't be shy. Like I said, we have plenty of time. We're gonna be Monday. We're mainly just finishing this. So we might not even go the full 2 hours on Monday.
Can you go over 20, please?
20, yeah. So let's look at 20. So on number 20, when you have an n in the exponent, or if you have a factorial, can someone tell me what usually
Ratio test.
test? Chris was ready. Okay, so I'm going to use ratio test here. So ratio test, if I want to know if it converges, I want to see if the limit as n approaches infinity is less than 1. Okay, so here, so limit n approaches infinity. Every n becomes an n. With, so about what I started with. So n times 3n over x minus 2 to the n to figure out what value make this less than 1. Okay, so I'm going to write this. On the base x minus 2, when I subtract the exponents n plus 1 minus n, that's just going to be 1. So x minus 2 is going to go into my numerator. And cancel out, because n is going to infinity, cancel out the n. And then when I focus on, you have 3 to the n over 3 to the n plus 1. You subtract the exponents there. So n, when you distribute the negative, it becomes minus n minus 1. So n minus n is 0. So you have 3 to the negative 1, which is 1/3. So I'm going to put 3 in my denominator. So where does this equal? Is less, if the absolute value is less than 1, that means x minus 2 over 3 is between -1 and 1. So skipping a few steps here, you just times everything by 3 and then add 2 everywhere. That will give you 5. And you have to check the endpoints. So if you plug in -1 into the original function, so test x equals -1. So when you plug -1 into the original, you have -3 to the n over n times 3 to the n. So this becomes 1 over n times -3 over 3 to the n, which is 1 over n times -1 to the n. So that's an alternating series. So this one converges by alternating series test. So if we just showed when x is -1, it converges. So that means I'm going to include -1. Now I'm going to test the other endpoint, which is 5. So when you plug 5 into the original, you have 5 minus 2, which is 3 to the n, over 3 to the n, times 1 over n. Well, this just cancels, and 1 over n is harmonic, so this one diverges. So my answer for this one, I'm not going to include 5 because it diverges when x equals 5. So my answer here is E. So that was a good one to look at. We looked at a lot of different concepts from series. So if you can do one like this problem, this covers a wide range of topics like alternating series tests, harmonic series, ratio tests, things like that. All of which are eligible for AP test: ratio test, alternating series, and P series, which includes harmonic. There's other questions on this page.
Can you go over 19?
19, you said?
Yeah.
Okay. So number 19. I'm gonna clear it out. I love not feeling rushed. It's always fun. All right, so 19. Also, I was gonna tell you, as we start going after next week, as we start kind of meeting the district's block schedule, we are probably gonna be meeting less than we are now. So, or even less than we are next week. I know I'm still planning on Monday, Wednesday meeting next week from 10 to noon, but because I'm teaching 2 different math classes, like I said, talk to the staff teacher, see what she's doing. So just know that we're not going to be meeting 6 hours on a normal week. This will be the last week we meet 6 hours. So I know this feels like a lot, but hopefully we have a mindset of finishing the year strong. And then after May 12th, that'll pretty much be it, sometime after the AP test. So you can totally go into full lazy mode after you're done with APs. I guess I can't speak for your other AP classes, but I can for this one. So I'm going to push you a little bit more now so that after the AP test, expectations of you. Okay, so number 19.
How's the whole block schedule gonna work?
They just announced it last night. I don't even remember, but it's basically like your math classes would meet like certain times during the week, your English classes would meet. So I'm kind of breaking the rules next week just because I wouldn't be able to cover what I need to from my classes. Planning on doing it the following week. I just had planned the entire schedule before I knew about the block schedule. So it's just, they're doing it based on the class. So like, I don't remember, maybe like English would meet from like 10 to 11:30. Math would be from like, I forgot what it was. I think it's actually Tuesday, and be any overlaps with your classes. But the thing they didn't consider is math. If you have AP stats and AP calculus, you'd be meeting at the same time. So that's the problem. So that's one of the reasons I'm just sticking with this, accommodate the block schedule better. So I'm not trying to be defiant. I want to accommodate AP stat students and also to finish multiple choice next week. That's the reason I'm going to keep with on that I sent on Google Classroom yesterday. Okay, so 19. Hopefully I answered your question. Okay, the block schedule is just, it's based on the subject. So like history will be elective, will meet different times during the week, and it'll be set. You'll probably be hearing about that soon if you. It tells me that, or it gives me the graph. If A1 and A2 are positive numbers that represent the areas of the shaded region, we want to find what this integral equals. So from -4 to 4, from -4 to 4, that would be A1 minus A2. And the reason it's minus A2, isn't A2, the integral, going to be negative because it's below the x-axis? So I would have to subtract a negative to make it a positive area because it tells me it's referring to the area, exactly the same. An integral can be positive or negative. Area is always positive. So that's why I have to subtract A2 to represent this here. So it's -2. And if you want to find the area from -1 to 4, that's going to be, again, it has to be -A2 because all of this right here, probably should have used highlighter, but all of this is below the x-axis. So I need to subtract it, take the opposite of that to make it positive area. So I'm just going to simplify this now. So when I simplify this, I have A1, like the steak sauce, minus A2. Negative times negative is a positive. So when you combine like terms here, it's going to be A1 minus A or B. And that's the wrong answer. Lame. A1 minus A2. Did I combine like?
You combined wrong.
I combined wrong. This should be plus. Thank you. Good thing. I was pretty confident that. In like terms, this should be A2. So 2A2 minus A2 is plus 1A2. So that would be letter D. So remember, integral can be positive or negative. Area, when it's just referring to the area of a region, area is always positive.
Thank
you. Mm-hmm. Okay, other questions on this page? Through 23, I believe. Everyone's okay on this page?
Yeah.
All right, let's go next page. Probably do a couple more today and then we'll wrap it up. We're almost done here. Like I said, after this week, I'm never gonna ask you to meet 6 hours on Zoom again. I know this is a lot. So I appreciate you guys that have been willing to ask of meeting this much on Zoom. But I think it's gonna be really helpful to get through the multiple choice next week. And we can focus all of our attention on free response for how I have things mapped out. Okay, so questions on 24 through 78.
24.
What's that? 24. Let's look at 24. Another Taylor series, which is based off of Taylor polynomials. So you won't see a Taylor series on the test, but you can see Taylor polynomials. So they go together, polynomials. So for this one here, it doesn't usually give you sine x, but here it does. So if you want to find the coefficient of x to the 7th, what you would do here is, well, first I'm going to find sine of x squared. So if sine x equals x minus x cubed over 3 factorial plus x to the 5th over 5 factorial minus dot, dot, dot. So when I plug in x squared, everywhere I see an x, it's going to look like this. X it's asking about the derivative. So I'm going to take the derivative of both sides now. Because right here it says f prime of x. I'm going to take the derivative of the left side, which is what I'm solving for. What's that?
Why don't you take the integral because you're trying to find Taylor series of f of x, not f.
Oh, is it? Okay. Thank you. So this is what, got that. So this is what f prime equals, and it's asking about the original function. So it's asking about f of x. So to get to f of x, I have to take the integral of both sides. Okay, so when you take the integral here, I would say f of x equals, it's going to be x cubed over 3 minus 3 factorial is 6. So when you have x to the, and it's asking me the coefficient of x to the 7. So I have that. It's right here. There's an invisible 1 right here. So it's negative 1 over 6 times 7 is my coefficient of x to the 7. So that's going to simplify to negative 1 over 42. That's going to be letter
Wait, why is
D.
it 6 times 7 again? 6 times 7 again?
Why is it what?
Like that. Okay,
because 3 factorial becomes 6. And then where the 7 comes from, when you take the integral of x to the 6, you get here.
Okay. Okay.
Is that okay?
Oh,
Give it like
yeah.
this. I'll just write it out. So it's x to the 6 over 6. And I can pull out the negative. You can even pull out the negative 1, 6. So negative 1 times x to the 7, which simplifies negative 142.
Wait, so for the sine x squared,
Mhm.
did you multiply by, wait, what
For,
did you do there again?
for sine of x squared, I just plugged x squared everywhere I had an x here. So everywhere I had an x, I just changed that x to x squared.
Okay, okay. Oh, okay, so yeah, it was like x
Yeah, so I was just
squared
raising
used
x
to
squared
go-
to all of
okay,
those
okay,
exponents.
Okay, okay.
All right, so maybe I'll do wage.
78.
78. Let's look at 78. Oh, well, then we'll pick up where we left off on Monday. Okay, so 78. So this is a calculator question, but that doesn't mean you have to use a calculator. So this is one you don't have to use a calculator, even though it's in the. So for this one here, this is going to be prime. This is the same as f prime of e, because this goes back to our definition of derivative using limits. We didn't just do that to torture you. I know we had shortcuts that we learned in chapter 3, but first we did chapter 2 when we introduced chapter 3, where we defined the derivative as using based off of limits. So if I was to do ln of e plus h, what does that turn into? Let's see. I'm sorry, this is actually this would be the original function here. Would just be ln of x. And that's because if you're using the limit definition, it would be limit as h approaches 0 of, you have ln, and you'd be for x equals e. So you'd be getting the derivative x equals e. So limit of ln of e plus h. Let me kind of work backwards here. So it's, let me undo this. So it's the original function, or it's, what is it, f of x plus h minus f of x over, is that the right one? X plus h minus f of x over h. So if x is equal to e, you put e in for ln of x. This is a tough one because you really have to have a good conceptual understanding of what's going on. So this would equal, if e is your x, it would be ln of e plus h minus f of e over h, and you're taking the limit as h approaches 0. And then when you simplify this, so it's kind of like you have to work backwards on this one. Figure out what would get, using this definition of derivative, this definition right here, the one that I'm circling, if it shows up. If you simplify this, you would have the limit as h approaches 0 of ln of e plus h. If you find f of e, you plug e back into the original function. So ln of e is just going to be 1 over h, and that's equivalent to what you have here. So it's kind of like one would get you back to where you started. So if you looked at, which one is that? That's, well, the good news is that's letter A. So if you started with letter A, you would see that using the limit definition of derivative, that would get you back to that statement that you started with in the problem. So any questions on 78? Okay.